Hello, everybody. My name is Nate Wood, at WoodenSec on Twitter, and this is All Juiced Up about DIY battery packs and more. Really, the what is about recycling batteries. Salvage them from old and used equipment to build or restore a new project. Some use cases include, Powerwall, UPS repair or retrofit existing electronics or power tools. Additionally, you could probably also use it for a hot swappable battery grip for your camera. It carries 2 batteries on board on the left side. And then the rechargeable battery controller is pretty cool. You can game all day on that one. 3D printed drone or accessory pack for your drone to build a racing drone out of these things too. My project, however, was a Power Wheels battery overhaul and overvolt. I got this Power Wheels from a friend for free, and the battery was garbage. And so we decided to, I decided to geek out and buy a bunch of batteries online so I could build my own battery pack for it. Easy, right? Just build your own battery pack. Some of the components that went into this is 18650 is the model of the battery, nickel strip to connect the batteries in between each other, or a nickel strip fuse, which you see on the top. Cell holders to kind of organize them and keep them all in one spot. Your battery management system, charger for your cells, a charger for your battery pack as well. And then just electronic tools that you would normally use in hacking like this or whatever, multimeter, soldering iron, spot welder. The spot welder itself is what you use to connect the batteries together via connection to the fuse there. So the battery management system, though, is what's there to control the voltage. It keeps each of the series of batteries charged evenly and provides over and under voltage protection. It's designed to open the ground circuit if the battery draws too much amps or is too low on voltage for any of the series of cells. So each one of these rows of cells, as you'll see in the pictures coming up, are balanced, and it won't let them go too low because you can damage the batteries permanently if they let go too low on their voltage. So the batteries that I used, I bought them on batteryhookup.com, and I'm in no way affiliated with the resource, but they're out of modem cell battery. They're out of modem batteries, and on the right there you can see the charger that I used, but they're pretty affordable if you can find them in stock. Right now I think they're out of stock, but it's 2 for $4, so 50 cents a battery. You buy $100 or $25 worth of batteries plus shipping. It's pretty cheap to come up with a project. The charger on the right, though, is individually charging and measuring the voltages of each of the batteries and slowly charges them from a low state, which you typically receive batteries in from the battery pack because they've just been sitting for a while. So battery design. Desired capacity and voltage is determined by how many batteries that you have in the pack itself. Series and parallel, some basic electrical theory here. You increase your voltage as you connect them in series. And then if you connect them in parallel, you increase your capacity for the battery. And so each of the 18650s has a 3.6 volt rating and a 2.6 amp hour rating, and that's just how many hours per amp that you use the battery for. The first example on the top shows 2 series and 1 parallel, which will work out to be 7.4 volts and 2.6 amp hours. And then the second example shows 2 series and 2 parallel, which is the same 7.4 volts, but you increase your capacity in amp hour rating to 5.2. That doesn't sound right. 7.2. Anyway, so they come in the battery pack and they're hard shelled and glued together. So I use these big shears, if you will, to kind of break the case open and then rip them apart. Highly recommend using gloves for that part because it's all sharp and pointy. But the cells have a little tiny battery management controller on the top there to control whether or not the batteries are charging and discharging and under voltage protection, like I mentioned. And then there's tiny leads in between the batteries to measure the voltage and to charge, and et cetera. And then after you remove all this excess components, you strip off the connections, and you're left with individual cells. So then you have to go and test them all with a multimeter to make sure that they're viable, and then potentially have to charge them individually before any other charger might be able to charge them, because a lot of chargers won't charge under a certain voltage, but you can still kind of jumpstart the battery itself by doing a little bit of jumpers between batteries. So the battery pack I'm designing is a 6P, 6 parallel, and 7S, a 7 series battery, which is going to work out to be about 29 volts and 93 amp hours. From the left to the right on the photos here, you can see the battery cells being set up in series and parallel. It's kind of hard to see on this photo, but the ones with the tops that have a black circle are the positive sides, and then the ones that don't have those are the negative sides, so it alternates. And you connect them together to make the series. So the top has the strip all the way down, and then there's an opposing strip on the bottom to connect to them top to bottom through the whole thing. The nickel fuse, though, is rated to a certain amount of current draw and will just kind of burn up in the event that it's overdrawn on current. So it's kind of a safety feature of that thing, but also you don't want to put it in something like your kids' Power Wheel toys that's going to burn up, I suppose. I'm just kidding. It's safe. The positive and negative bus bars, which are the large gauge wires on the far picture there, connect each battery. If you don't connect them all together at the end, your power draw all goes through this one small connection. It doesn't matter how big the wire is. It all gets too concentrated, and then you burn up the nickel fuse. And then the battery management system is kind of in the corner there. It's green, and it's got those wires. Each of the white wires are going to a strip of connectors, and does all the battery management and balancing and stuff like that, as I previously said. So the Power Wheels truck, on the right, or the left, you can see the installed wiring project. It's got a controller for speed. That's the one with the knob on it. And then I replaced the connectors to be much more plug and play. And then there's a buck converter right there to run auxiliary systems. In the middle, you can see that I retrofitted some cool switches for the kids to turn on and off the master power or turn on and off the high and low beams, which you can see in the far photo there. There's one more switch in there for future expansion ideas. Whenever they get into music or something, maybe they have a stereo, I don't know. So what does this all run out to be by a cost comparison? Is it worth it to do your own battery pack for this purpose? I would say maybe. I mean, it's a lot more upfront investment, but you get a lot more battery and usage out of the thing in the first place. So I forgot to put this thing up here. But the new Power Wheels battery are really heavy, take forever to charge. They're only 9 amp hours, and they're only 12 volts. The cool thing about Power Wheels is that they're only rated for 12, but most times you can just kind of turn up the voltage, and they start spinning and going faster. I had some extra parts in here. I underestimated the total current draw of the battery pack. The first 25 amp BMS was cutting out due to the lack of the truck drawing too much current on the initial takeoff. To get the thing moving, it has to draw more amps to get it moving than it does to keep it moving. So the 50 amp BMS can handle the more initial current draw, and I think I'm still bottlenecked right now by my speed controller, which is not, I don't think it's rated quite high enough for being able to turn it all the way up. I think it's 60 to 70% of the voltage, so it's probably like 18, 20 volts with the single rider. And if it's going up a hill, it's always more difficult. My backyard's kind of hilly. But my old battery pack lasted about 20 minutes and took 4 hours to charge. And it's kind of hard to explain that to your kids, like, why isn't it working? Well, it's got to charge again. But this one charges in about 2 hours and lasts pretty much all day. They usually get bored with it and move on to something else before they end up running up the battery pack out. So, and here's the results. I don't think I have sound on this one. Oh, I didn't plug the sound in. It might be hard to tell how fast these things are going compared to a regular one, but they are going significantly faster. And so you run into some odds and ends where you're like surprised by you running over the tree. Yeah, that's my talk, and yeah, Christian's right here in front. He was able to come down and see, but he's a great driver now. All right, that's it. Thank you. Yeah, I'll take questions, of course.
Question. How did you determine what was the capacity of the electric motor that you were driving, so that you wouldn't, smoke the motor? And also in your battery pack, did you have any infant mortality of any of the batteries that didn't fail your initial testing or that failed soon after that you had to rebuild the pack?
I ran into no truly dead batteries. Out of 100, I think I had to jump start 4 or 5 of them, but most every one of them was decent enough to at least take a new charge. And in terms of building the pack, I had one where the self-nickel fuse burned up when I didn't, as I mentioned, I didn't put my bus bar all the way across, and so it draws too much amperage through one battery, thus burning up the fuse that's intended to burn up. And in terms of knowing whether or not it's going to smoke the motor, well, I don't really think I did enough, or I didn't really plan that out. I just planned to replace them if they go bad, I think. So you see the motors get stripped out because the power gets too high. And there's a whole community, I didn't put it on here, but Power Wheel mods on Reddit, batteryhookup.com, and 18650 Master Race is the battery subreddit for this one. But yeah, I think that answers the questions. Yeah.
How would you look with the spot welder? I think some of those small battery pack spot welders keep it exploding.
It hasn't exploded on me yet. My friend Scott just didn't mention that part. Anything else? Yeah.
For your BMS, do you have any advice on how to spec that out? Or?
Yeah, so you got to base it on how many things you have in series and how much your estimated amperage draw was. And I underestimated how much current would be drawn in the first one, and so I had to replace that one. But so the number of series determines the number of wires that come out of that thing to monitor each of the series of batteries and make sure that it doesn't go undervolted and stuff like that. So, all right, thank you, everybody.